We're going to do this quick because you should have learned about a lot of this on the video, right? How to solve a quadratic equation. There's 5 things to look for. I've got them in an order of a hierarchy. The first thing, the easiest thing to look for of how to solve a quadratic equation is called the square root method. The only time you can use it, though, is when there's no x to the firsts. Is that a quadratic equation? Yes or no? It's not in standard form. It's not in vertex form. Is it an equation? Yes or no? Yes. Is the biggest exponent in there a 2? Yes or no? But you also see that there's no x to the firsts in there at all. How would you solve for x? You would square root both sides, correct? You would say x equals plus or minus 2 because you did the square root method. There was no x to the firsts in there, square root method. Second thing to look for is if you could factor it. I made a little tree for you. If there are 2 terms, the only way, I shouldn't say the only way, the most popular way to factor something that has 2 terms is a difference of squares. For example, isn't that a perfect square? 4x squared. Isn't this a perfect square? Correct? And they are being subtracted. The difference of squares factors into conjugates. You might make a note for yourself. They factor into conjugates of each other. That's a cool word. Conjugates. Meaning that would have factored to 2x plus 3 and 2x minus 3. Conjugates. It almost looks like the exact same thing in both ordered pairs, but what's the difference between those 2 bad boys? The sign. Cool. 3 terms, the first thing to look for is if it's a perfect square trinomial. I've typed it out for you already. How do you know if something's a perfect square trinomial? The first term's a perfect square, the last term's a perfect square, and the middle term is twice the product of the square roots. We'll come across those later. The next easiest thing after that is if it's easily factorable. That's when the a value is 1, which you had on your homework that was due today. And then the last way to factor, the way that sucks the most, it's called frowny face for a reason because it sucks. It's called frowny face factor. At least that's what I call it anyway. If you cannot factor something, that doesn't mean you can't solve it. Not every quadratic equation can be factored. The next thing we would look for is to complete the square. But there's only a certain time when I'd want to complete the square because you can complete the square on anything, but it sucks a lot of times. It does not suck if a is 1 and b is even. The only time you can complete the square is if a is 1. That always has to happen. If b is an even number, it'll be very, very easy to do. And when would I do it? When that happens and it's not easily factorable in the first place. If completing the square is not an option and factoring is not an option, then I would go with the quadratic formula, which I want us to write right here. The quadratic formula is x equals, what is it? Let me erase this little nugget out of my way. The opposite of b plus or minus square root of b squared minus 4ac, and all of that is over 2 times a. And when would I use the quadratic formula? I mean, it works every time, but sometimes it's just a mess. It's just way too long. If you can factor something, it takes you 3 seconds. Do the quadratic formula, it takes too long. When would I use it? When the numbers are really large, even if some of these work, but when there's really big numbers, I'd rather use the quadratic formula because I don't want to find 2 numbers that multiply together to be 3,085 and add together to be 264. It's like I just don't want to do that. It's like that's way too big of numbers. Finally, you could use your graphic calculator to, when you need an approximate answer, like in a story problem, like with our graph that we just had of this ball going down, you could just calculate where it crosses the x-axis because that's what you're doing. You're figuring out when x equals 0. You're finding the x-intercepts. So boom, you're finding the roots, all that stuff. Boom! Let's go through it. Here's examples of each kind. Square root method. How do I know I can use the square root method? There are no x to the firsts. Would you agree? In this problem, there are no x to the firsts. Get x squared all by itself on one side of the equal sign. Wouldn't you have to add 7 to both sides? Right? Then to solve, since x squared is all by itself, square root, you got to realize that you get 2 answers though. 7 is not a perfect square, so I will just leave him as plus or minus the square root of 7. Any questions about the square root method? Only time you can use it is if there's no x to the firsts. GCF is the next method. That stands for greatest common factor. Look here. Doesn't everything have a multiple of 5 in it? Doesn't it also have a multiple of x in it? So I will take out a factor of 5x. Right? 5x is the greatest common factor. It's like the reverse distributive property is really what's going on here. If you take 5x squared and divide it by 5x, you will get 1x back. Minus sign comes down. 20 divided by 5 is 4, and x's cancel each other out. Cool. And now you use the zero product property to solve this. So what value of x makes him 0? X could equal 0. Or what value of x makes this quantity come out to be 0? 4. There's our two solutions. If you totally graph this, take a guess what happens. That parabola crosses the x-axis at 0 and 4. These are the x-intercepts of the graph right here. Next guy, perfect square trinomial. Right, that's what PST stands for. First term's a perfect square. Would you agree? Bring down his square root right here. 2x. Isn't that the square root of 4x? Is the last term a perfect square? 9? You bet. What's the square root of 9? 3. But don't put a sign yet. You need to bring down this guy's sign. Whatever sign that is goes right here. That factors into that entire quantity squared. If my pen would wake up, sorry. It's still equal to 0. Let's double check though. Let's see if he really was a perfect square trinomial. I told you it was a perfect square trinomial. But to be a perfect square trinomial, first guy's got to be perfect square, check. Last guy's got to be a perfect square, check. And then the middle term has to be twice the product of those square roots. If you multiplied those together, wouldn't you get 6x? Double it, don't you get 12x? Isn't that twice the product of those square roots right there? Cool. And now to solve this, you use the square root method. Because you've got an entire quantity being squared, you just square root both sides. If this turns out to cancel each other out, you're left with 2x plus 3 equals the square root of 0. There's no need to put plus or minus 0 because it's just plain old 0. Awesome. Then you solve for x. Subtract 3 to both sides and divide by 2. And this parabola crosses the x-axis at -3 halves. It only crossed in one place because that means the vertex is touching the x-axis right there. This is also a perfect square trinomial problem right here. But the difference is, oh no, it's not equal to 0. Don't get it equal to 0. Because this is a perfect square trinomial. Notice the first term's a perfect square. What's his square root? 4x. The last term is a perfect square. A lot of people forget about 1 being a perfect square. Square root of 1 is 1, correct? Then I need to bring the sign down. Wait a minute, this isn't a perfect square trinomial. Well, let's change it to be a perfect square trinomial. Let's call that 8x right there. My bad, I made a typing mistake. Let's call that 8x instead of 32x. Y'all cool with that? Is the middle guy twice the product of the square roots? Now it is. And it's still equal to 11. Awesome-o? Still equal to 11. Sorry for the typo. What do I need to do to solve? Square root both sides. This guy becomes 4x plus 1. On the right side, now you need plus or minus the square root of 11. Get x all by itself. Let me subtract 1 from both sides. -1 plus or minus the square root of 11. So far, so good. Divide by 4 to both sides. X equals -1 plus or minus the square root of 11 all over 4. Just like if you do the quadratic formula on that one, that's what you get for your answer in the quadratic formula. This was faster, in my opinion, if you understand the perfect square trinomial stuff, which I know that's pretty new to you guys. Okay? Difference of squares. It's a subtraction problem. There's only 2 terms on the left side, and both of those things are perfect squares, correct? They factor into conjugates of each other. Make yourself 2 parentheses times each other, equal and 0. All you got to do is square root each thing. What's the square root of 4x squared? It's a 2x. He goes at the beginning of each quantity. Square root of 9 is 3. He goes at the end of each quantity. And what you need is just to alternate the signs. It doesn't matter which one's which. One of them is a plus, and one of them is a minus, baby. Now we solve this with the zero product property. what value of x would make this turn out to be 0? Opposite of this over this. What's this number's opposite? Negative 3 over 2. That would make this 0. Or, what value would make this guy turn out to be 0? Opposite of this number over that one. What would you get? 3 over 2. That's where this thing crosses the x-axis. Please do that on the other difference of squares. This is a subtraction problem. There are only 2 terms, and each term is a perfect square. That's why it is a difference of squares. So set them up as 2 parentheses equal to 0. Square roots go in. 7, 7. Signs are different. It doesn't matter which one's positive, which one's negative. They just have to be different. Then to solve, opposite of this guy over that guy. Opposite of this guy over that guy. When you have a difference of squares situation, your 2 answers should be the exact opposite of each other. Cool? Awesome. We're getting closer. Easily factorable. A value is 1. Find 2 numbers that multiply together to be 12, add together to be a negative 7. The hardest part about that is finding the 2 numbers. So you need to think about the signs first. If they multiply together to be 12, should the numbers both be positive, both be negative, or one of them be negative? Well, you know they can't one of them be negative because they have to multiply together to be a positive, correct? Let this sign tell you what's going on. 2 positive numbers cannot add up to be negative 7, correct? So it has to be 2 negative numbers. What are 2 negative numbers that multiply together to be 12 and add together to be negative 7? Negative 3, negative 4. Doesn't matter what order they go in. Simply factored into those 2 quantities. That's why it's called easily factorable, because you don't have to go through that whole mess of splitting it up and factoring it by grouping. Solve for x. X could equal 3 or 4. All right, what value makes this 0 if x was 3? What value makes that one 0 if x was 4? Frowny face factor. Why? Because the a value is not 1. So I make that little frowny face and I multiply a times c, negative 8. Correct? Now I need to find 2 numbers that multiply together to be negative 8 and add together to be a negative 9. Since they have to multiply together to be a negative, would you agree that one number has to be positive and one number has to be negative? So multiples of 9, 1 and 9, but one of them has to be negative. Oh, multiples of 8, sorry. Multiples of 8, 1 and 8, but one of them has to be negative. I think I did this backwards. Neither one of those add together to be negative 9. Multiples of 8, 2 and 4, one of them has to be negative. Not going to happen. Multiples of 8, that's it. Another typo on my part. So, frowny face factor, I'll make up another example another day. But it was on your practice sheet, correct? My bad. Hey, that's what happens when you type these over the summer, you know? It's like, sorry, I'm watching Family Feud, and I'm trying to make a worksheet at the same time. Complete the square. Complete the square. Is A1? Is B even? And notice you can't factor this. You cannot find 2 numbers that multiply together to be a negative 3 and add together to be a 4. Because the 2 numbers that multiply together to be negative 3, these are your only combos. They do not add together to be 4. So since A is 1 and B is even, though, completing the square is actually a pretty simple case. Set her up with blanks. X squared plus 4x plus blank. We also want to bring all the constants over to the other side, so we're going to add 3 over here and also put a plus blank over there. Why do you put a plus blank on both sides? Because you got to keep it balanced. If you're going to add a number to the left side, you got to add a number to the right side. How do you complete the square? Take half the b value. Reason why you want it to be even, because doesn't half of an even number come out nice? What's half the b value? It's 2. Then square it. What do you get? 4 goes in the blank. 4 goes into this blank. If I add 4 to the left side of the equation, I have to add 4 to the right side. The reason why we did that is because this is now a perfect square trinomial. We are completing the perfect square trinomial. He factors very simply to be the square root of him and the square root of him, and whatever sign you are right there, quantity squared. Same perfect square trinomial trick we did before. Square root of your first dude, square root of your last dude, sign comes in the middle, the quantity's being squared, and over here, don't you have a 7? 3 plus 4. Square root both guys. This becomes x plus 2, and this is plus or minus square root of 7. So far, so good? To get x all by itself, subtract 2 from both sides. And there's our answer. X equals negative 2 plus or minus the square root of 7. Let's do that one more time. Set it up with blanks. And then subtract that guy over also. A is 1, B is even, and this is not factorable, so that's why we're completing the square. How do you fill in the blank? Half the B value squared. What number goes in the blank? 9. This guy factors to x and to 3, quantity squared, and the sign is negative, right? That sign right there is negative. Negative 11 plus 9. Uh-oh! How much? Negative 2. Uh-oh! SpaghettiOs! Now we have to square root both sides. When you square root this side and square root this side, this becomes x minus 3, and this can't happen in the real number system. But luckily, we know about imagination land. What is the square root of negative 2? It's square root of negative 1 times the square root of positive 2. But what's the square root of negative 1, my friends? It's I, square roots of 2. That's what you have, and then you got to have plus or minus also. Plus or minus I, square roots of 2. Cool? Then add 3 to both sides. X equals 3 plus or minus I, square roots of 2. In the real number system, depending on what my math lab says, you'd say no real solutions. In the complex number system, we'd have this. And then the quadratic formula, let's realize why you would use the quadratic formula on this. Maybe, just maybe, it was factorable. But would you really want to take 3 times negative 35, get that big old number, and find two numbers that multiply together to be that, and add together to be negative 14? It would take you too much time. By the time you did the quadratic formula, you'd be done. You just substitute, since A is 3, B is negative 14, and C is negative 35, you substitute those into the quadratic formula and find your two answers. Good?